Hi, my name is Kristen Kinsevich, and I am a student at Regent University. And I'm going through an experiment or an exercise on data screening, and this was an assignment for multivariate statistics. And I'm going to show you what I did to walk through this assignment, and it's helpful information for data screening and tests of normality, so this might be one to come back to. So I have been given this data file by my professor, but if you're looking for the data file and you don't have a different way to upload it, you can type in your search engine using multivariate statistics data files, and then you'll see this companion website for using multivariate statistics. This goes along with the textbook that we're using, which is called Using Multivariate Statistics. It's by Barbara Tabachnik and Linda Fidel. I'm using the 5th edition, so the page numbers will correspond with the 5th edition. You can click on that companion website and go down. I'll be using the SPSS files, so you can click on SPSS files. And their file for this is called screen because you're doing the data screening. And so I've already opened that, and so I'm going to go ahead and open that. And actually, I'm going to get rid of this output so that it doesn't confuse us later because we're starting from the beginning. So what you want to do first is understand what you're looking at. And so this was a study that was apparently done in the 70s with women. It's looking at the frequency of going to visits to health professionals, and it looked at the women's attitudes towards medication, their attitudes towards housework, their income. Employment was actually a grouped variable. We may not talk about it much here because it's something that they use if you're using the SAS statistics program. Marital status here and race. And so we'll be talking about all those variables. So the first step that we want to actually think about prior to data screening is just to imagine if we were the researchers, what type of research question we might ask. And so for the assignment that I had, we had to just come up with a research question using multiple predictors. And so you can really choose any variables that you want. The research question that I came up with was, when taken together, do race, marital status, and attitudes towards medication predict the number of visits to health professionals? So that's a multiple regression type of question, and we'd be looking for multiple layers of data normality, which we will go through in this video. So that's just kind of for fun to think about a research question that you would be, what would you be curious about with this data? But that's really a separate thing. Once you've come up with a research question, we're not actually going to be following up with that question and analyzing that question. We're just going to be looking at things like the data itself. Is there any missing data? Is it accurately typed into SPSS, etc.? So the first thing that we're going to look at is that accuracy of data input. We're looking for missing data or missing cases. We're looking for normal distributions. And at this point, we're looking for univariate outliers. And so the way that you're going to do that is by going up to Analyze. You're going to click on Descriptive Statistics, and you're going to click on Frequencies. Now, I had already done this earlier, so it already has it listed. Let me just put all these back so that I can walk you through what I did. We're going to ignore subject number for right now, but we're going to look at visits to health professionals as one variable, attitudes towards medication. There we go. Come on. It's having trouble. Sorry. There we go. Attitudes towards housework. There we go. Works to double click. Income. We're going to skip whether they're currently employed because, again, that's a grouped variable, which is something that they gave a 0 or a 1 to after the fact. And so we're not going to consider that one, but we are going to click on whether they're currently married and also race. Now we want to click on statistics, and we want to click on down here standard deviation, variance, minimum, maximum, and SE mean. We also want to make sure that skewness and kurtosis are checked off, because we're gonna want to look at all of those data. And then in charts, we want to click on charts and make sure you've clicked on histograms and show normal curve on histogram, because that is just visually helpful when you're looking for normal distribution. So you're going to hit continue and then go ahead and click OK. And at the top, you're going to see this syntax. We'll scroll back up there. It's loading all these different charts. And so on page 94 of the textbook, you'll see a syntax that should look exactly like what we have here. The only difference is there is a format that they have. It says format equals notable, and that is a stylistic issue. So if we had typed that in, which we could have done, then we would have a slightly different style. But right now, we'll just look at, make sure we have the data that we need. So it says frequencies, variables, and it has the variables time DRS, which is time, the number of times going to the doctor. ATT drug is the attitudes towards medication. ATT house is their attitudes towards housework. Then you have income, marital status, and race. So those should be listed. If you don't have those listed, then you missed something when we click those variables over. Then for statistics, we're going to want to have the standard deviation, variance, minimum, maximum, the SE mean, skewness, SE skew, kurtosis, SE curt, and histogram normal. And then it should say order equals analysis. So that should all match the syntax on page 94. And so now we have some information, and we're looking for some specific things. First, we want to make sure that the data has all been entered correctly. And if it was not entered correctly, there would be values that would be outside of the normal ranges, perhaps. Certainly, there could be errors that are not particularly detectable, but we're looking for major mistakes. And so if you look at kind of the different tables that you have below, you can take a look and see that they all do fall within the range that they are supposed to. And we'll look at the histograms in a second. But the minimum and maximum here show you the range of what the values should be. And so you can look, is there anything less than 0 or more than 81, less than 5 or more than 10, etc. Anything that would be outside of these numbers means that there was a mistake. Now, if you go along with the book, you'll get a hint that there are no mistakes that we can find. Everything seems within the normal ranges, and so that is good. That's kind of step number 1. Then we're looking for missing data, and here on this line you see missing. And so we see that there's no missing data for the variable of visits to health professionals or attitude toward medication, but we do have one missing, attitudes towards housework here. And then income, we have 26 missing cases here, so that's pretty significant. The book says that it is actually more than 5% of the cases, and so that's definitely a problem. Whether they're currently married, the marital status, that is no missing cases, and also race, none missing. So we really just have this one here, and then in the text, they really recommend just eliminating income. If your research question had something to do with income, you may want to change that because you'll lose a significant amount of data. So unless it was really central to the thing that you were looking for, in which case there are some things you could possibly do. But with that number of cases, that would be a significant amount of data to either change or the number of cases to eliminate. So for now, we're going to just ignore income and decide not to look at that at all. And so we have this attitudes towards housework. And so what we can do with that one is actually look down here where it says the mean on that. And did I miss that again? Okay, let me see if I have the mean. There we go. It's down here with the histogram. So if you go down, and it was attitudes towards housework that we were looking for, there's a missing one. The mean is listed right here, 23.54. And so what you can do is, in the case that's missing, which if we go back to our data, we will look for the one that is missing. And you can do that either visually, just on your own, look for the one that's missing. And I think there was another way. Let me just see. I'm not remembering at the moment if there was an easier way to find the missing one. And so I think what we can do is just take a glance here and we'll find it together. It's attitudes towards housework, and we're just looking really for an empty box. So let's just scroll down. I'm going pretty fast just to look for that empty box. And you'll notice that there's no decimal points in here, so all of these numbers are rounded up. And so our 23.7 or whatever, here it is, number 253, we're going to go ahead and enter. If we put 23.7, that's going to change it anyway to 24, if you see right there. See, so it changed it to a 24. So basically we just chose to put in the mean there, and that replaces the information that was missing, which is an acceptable thing to do in this case so that we have a complete amount of data. So now we'll just go ahead and hit save on that so that we save our data set correctly. And then we're going to go back to our output and take a look at tests of normality. And so you can see here that the visits to health professionals does not have a normal distribution. You can see the curve right here and how the shape it's supposed to be, and instead it starts up here and goes down this way. And so that's going to be a problem we're going to talk about fixing in a little bit. We're going to have to do something about that. But if we keep going and we look at the attitude towards medication, we have a beautiful bell curve right here. And so that is a normally distributed variable. We can also look at the skewness and kurtosis way up here at the top, and each variable, it lists the skewness and the kurtosis. Now, a perfect normal distribution, skewness and kurtosis would be 0. So we are looking for values close to 0. You can see the visits to health professionals, that's a 3.248 and a 13.101. Those are pretty far from 0, and so we already saw from the histogram it was not a normal distribution. We'll need to fix that. But the attitude toward medication, pretty close, a negative 0.123 and a negative 0.447. We'll take a look at the others and we'll go back to the histograms. Right here, the skewness, again, pretty close, a little bit high here, but we did just add in the missing value too, and so that might help. We've got income here, which we've decided we're probably going to skip over because of the number of missing cases, so we can move on over here. Now, these two, marital status and race, are dichotomous variables. It's just zeros and ones because they're either married or not married, and also their race is either white or non-white in this particular study. And so those are not normally distributed, and you can see if we go down to the frequency table for those two variables, you'll see the 1, which we'd have to go and check which one is married or not married, but I believe 1 is not married and 2 is married. So you've got 103 women who were not married and 362 that were. Ideally, it'd be split in half, and so you'd have a nice even split. That would help with generalizing your findings at the end, but it's not the end of the world if you don't have those numbers perfectly aligned. You see here that for race, number 1 was white, and so 424 in your sample are white versus 41 who are non-white. Obviously, you can see the percentages there. That's not great, but that just means that you have to be careful about generalizing your findings. And so we'll talk a little bit more about that later on. But for now, we don't have to worry about a normal distribution on those two variables because they are dichotomous. So really what we've decided is that visits to health professionals needs some help because it does not meet the assumptions for normal distribution. Attitudes towards medication is fine. Attitudes towards housework is fine. But we actually didn't get to talk yet about this little guy over here. This is an outlier. And that's what we're looking for, where we see this beautiful normal distribution, except for this one here. So we're going to have to go and look at that in a minute to also eliminate. That's a univariate outlier because it's just on one variable. We're not looking at combinations of variables right now. And so we'll take a look at that in a minute and fix that. Income, we've decided we're going to ignore. And these are the currently married and the race, which, as you can see, we don't need to worry about the normal distribution there. Okay, so now what we want to do is go on and deal with those outliers and also deal with the non-normal distribution on the visits for to help the visits to health professionals. And so what we're going to do is actually, you know what, we're going to come back to that. I'm going to show you how to transform that in a minute, because before we do that, we are just taking note of the fact that there are the outliers in a couple of the cases. If you look at page, all of this, by the way, is on page 94 and 95. Your table and your histograms should match that exactly. And if it doesn't, then you did something wrong and you need to go back and double check which boxes you clicked. But for now, I want to draw your attention to page 96. It mentions on this attitudes towards housework the 2 extremely low scores of 2. Those are the outliers, and so we will do something with those outliers right now. And what we need to do is really just eliminate them. And so if we go back to our data, we're going to just click on data, and we're going to do select cases. And we're going to look at attitudes towards housework if condition is satisfied. And so we're just going to want to see the cases where attitudes towards housework is greater than 2, because the book tells us, and we could look at the data for ourselves to see that the score of 2, there were 2 cases that had that extremely low score, and that was messing up our bell curve. So we're going to go ahead and click continue. Come on. There we go. And hit OK after that. Again, if you wanted to do your own syntax here, you could click paste, but we're going to go ahead and hit OK. And there you see the syntax where it says filter, attitude house is greater than 2. And what that does in our data file is, if you scroll over here, you'll see this slashed line right here. There should be 2 of those because there's 2 outliers, 1, 2. And so all the rest of the data is there for us, but that means that we will have 463 cases that we're analyzing rather than 465. So we'll save it that way again. Now, if you close that, it may not save that specific selection. So if you come back to this later, you may have to do that step again. So you would just go to Data, select Cases, and then specify if attitudes towards housework is greater than 2, then that's the ones we want to keep. So you may have to do that step again if you close and come back to it. Okay, so we've dealt with those 2 outliers, and now we're going to actually, before we transform the visits to health professionals to make that a normal distribution, what we're going to actually look for is, hold on, I'm coming down to it. We're looking for the linearity and homoscedasticity. Good luck pronouncing that. Homoscedasticity. I'm sure someone out there can pronounce that better than me. Okay, so we are going to look for those 2 things, and the way we do that is described in the book. And so we're going to look at page 96, 4.212. And this is where we're going to look for the scatter plot that's on page 98. That's what's going to show us the linearity and that really tricky word, homoscedasticity. I'm still not doing it right. So what we want to do is go ahead and go to Graphs, and we want to go to Legacy Dialogues, and we want a scatter dot. And so it's a simple scatter. We're going to define that. And in the book, they have chosen to look at the visits to health professionals, which we know does not have normal distribution. And we're going to choose on the other axis, attitudes towards medication, because that one didn't have any outliers. It was a great normal distribution, the lowest number of skewness and kurtosis. So those are the closest to 0. So on the x-axis, we are going to put visits to health professionals, as you see there on page 98 in the book, as they have done. And then we're going to do attitudes towards medication on the y-axis. And I don't think we have, we don't need to do anything with the options or titles, and so we just go ahead and click OK. And then you get this graph in your output. And you see there that instead of having the dots kind of spread out and what would look kind of like an oval shape within that kind of rectangle right here, so the oval would kind of be like dots in the middle here and then fewer on the edges and then kind of more in the middle. Instead, you have all these clustered dots over to the side with dots kind of way out here. So it's not the right shape right now. And so because the visits to health professionals is not normally distributed, then it's also throwing off the linear relationship that we want to see. And so this is a problem, and we need to fix it. So basically, what we would say here is that the data is heteroscedastic at the moment. It is not homoscedastic. And so that, again, is a problem because you want it to be variable kind of evenly across this whole scatter plot. That would be homoscedastic. But hetero means it's not matching, and so that's this lopsidedness that we see here. So we would go ahead and still proceed with the fact that we have to transform that variable, time DRS, which is the visits to health professionals. And so that's what we're going to move on to do now. And so you can see the syntax on page 99 that they have. We're going to do a logarithmic transformation. And so what you're going to do is go back to that data file here, and you're going to click Transform Compute Variable. Now we're going to have a new variable, and we're going to follow what the book says. And so they have L time DRS. That's the L for the logarithmic transformation we're doing with that variable, time doctors, time DRS. And what we're going to do is type in what they have in that syntax on page 99. So they have compute L time DRS equals LG10, open parentheses, and then it's this variable right here. We want to just click on it, make sure we enter it exactly right. And then we need to do +1, because if there were any 0 values, then taking the logarithm of that would not produce anything but 0. And so we have to add a 1 to all of the values that we currently have, and then be able to take the log of that. That's why the parentheses are there. And so that is the formula that we're going to use. And again, this is with the data file limiting those 2 outlier cases, and so it's going to have 463 cases in our statistics. So we're going to go ahead and click OK. And in your output, you will see the syntax that we just did. And you won't see any other output at the moment, because what we have is we've created a new variable. And so that's going to be in your data file. Now, at the very end, this is the L time DRS new variable. And so we've transformed it, but now we have to find out if it helped. And so we go back over to Analyze and Descriptive Statistics. My cat is running around. If you hear a little bell ringing, he's going crazy right now. We're going to click on Frequencies again, just like we did. And now we don't need all of them because we have already looked at all of these, except we want to just know about the new one. So let's scoot all these back over here. We just want to know about that L time DRS. And so let's click on that one. Scoot it over here. So the only variable that we're looking at is here. And you see on page 99, the syntax there, it says frequencies, variables equals L time DRS. Again, they have the notable format, which we could click paste if we wanted to make it exactly the same. We could type it in. I'll just show you what that would look like. I'll click paste for a minute and show you. If we click paste, it pops up this syntax editor. So we could put /format notable here. Let's see what happens when we do that. Format. It may not work because it may be a specific format that they have, but let's just find out if it works. So we've entered that in. Then we have statistics, standard deviation, variance, minimum, maximum, mean, skewness, SE skew, kurtosis, SE kurtosis. Okay, and then we've got the histogram normal, order analysis. Now, all of those were checked off because we have done this already once. If you were to stop and come back to it, you may have to check off those boxes like we originally did in our first round of looking at normality. Now, if you want to run this syntax the way we've changed it, you just hit this green triangle button, run selection, and let's see what happens in our output. Okay, I don't see any particular difference with the format notable, so that was really an unnecessary step. We just were trying something for fun. But here we have the frequencies, and now we're trying to figure out, did it help? We want to look at skewness and kurtosis again. Remember, we want values close to 0. And here we have skewness of 0.221, kurtosis of negative 0.183. And so that is really good. And here our histogram, not perfect, but better, much better. And so that helps us proceed with any data analysis we're going to do. Now, you would probably want to go ahead and save this output as we go along here if something happens to your computer. So I've already saved other ones, but I'm going to go ahead and call this output A, just because I have other ones, and so I want it to be different. So I can go ahead and save that here. And in our data file, I think that it's still, oh, we want to save that, right, because we did the added variable. So go ahead and save that now so you don't lose that data. And then we also have this third window now, which is the syntax editor, and that you can save as well. Gotta click on that there and click save. And we'll just call that syntax 1. Okay. So now that's saved. So in case you have to come back to this later, you don't lose your place. All right, so now we've transformed the variable into the L time DRS with that formula. It was LG10, open parentheses, time DRS plus 1, close parentheses, and that takes the log of the original variable, adding 1 to eliminate any values of 0. And so after that transformation, you just can note that the skewness and kurtosis are improved and the histogram is better. If you were doing a write-up, you could note all of those things and then paste your output if your professor needs to see kind of what came out of that. And so now the last thing that we can do is, again, redo our little graph. We had tested for the linearity and the homoscedasticity, if I can ever say that word. And so going to the simple scatter in the scatter.graph, click define. And now we want to get rid of this x-axis, and we want to go ahead and click on the new variable, L time DRS. So we have still attitude source medication as the y-axis and the new variable as the x-axis. And so then we can go ahead and click OK, and it will spit out a graph for us. Now remember, we were looking for an oval shape. You kind of have to imagine an oval here, I suppose, but because it's inside of a rectangle, so the eye might not appreciate it being an oval. But you see how the dots are now much more in the middle. It's much more spread out. The edges are kind of wide on each edge, and so that does produce more of that linear relationship we're looking for, which is not surprising since the normality was fixed. And so that shows that you now have a linear relationship and homoscedasticity. So now we're going to look for multivariate outliers, and that we're gonna not look at the variable income anymore, and so we can forget about that. Let's go back to our data file here, and we're just following along in the book here, so we're still on page 99, and some of theirs, you can see the graph that we just looked at, this last output where we talked about the oval shape, that's on page 100. So we're just going along and doing what it is that the book has shown us to do. So now we're on page 99, 4.2.1.4, detecting multivariate outliers. And so it talks about this residuals equals outliers, MAHAL. That is the Mahalanobis distance command. I could not find that on a menu choice, and so I used the syntax editor to go ahead and look for that. And so what you want to do now, again, your two univariate outlier cases are eliminated. If you look over here and you scroll down, you should still have this little slash on 2 of your cases. So if you've just been continuously going through, that should still be all set. And now what you want to do is go up here to Analyze, and you want to go to Regression, Linear, click on that. Now, the dependent variable, they are using this subject number. And you can tell that because of the syntax on page 100. So it says regression down at the bottom of the page, regression, missing listwise. And if you go down, you can see where it says dependent sub no. And that's what they mean right here, subject number. So you're going to put that in the dependent. Then you're going to, you see down in the second to last line on page 100, in that syntax, it says method equals enter, ATT drug, so that's attitude towards medication. We're going to put that over the independents here. Come on. Hold on. What's it doing to me? There we go. Attitude towards medication. Attitude housework. So we'll put that next in the independent. Then we're going to skip income. And we're skipping employment because that is a grouped variable as they talk about in the textbook. So we're doing marital status as another independent predictor. Come on. This is giving me some trouble when I click on that, so don't give up. And then race down here. Oh, if you double click, it sends it back, so be careful there. Might take a minute. There we go. And then remember, we skipped visits to health professionals up here. We did not put that yet in here. And why? Because we changed that variable. Now this L time DRS is the one that shows, it has the normal distribution. So we're going to use that variable from now on. The other one we had to, kind of put aside. So we're going to click on that. And then we are ready to go, except let's check on statistics here and see. We want the collinearity diagnostics. We're going to need that later. We don't need descriptives because we already have that. And we're going to want these outlier statistics, but that is not in any menu that I can find. We do have method enter, and that is correct. So now what we're going to do is click paste. Because I clicked on plots, I clicked on options. Let me just click on plots again. Yeah, none of that is anything we need now. And the options does not give me a chance to choose this MAHAL, Mahal. So we are going to cancel that and we're going to click on paste. There we go. Oh, I know why, because it wants me to click on the syntax editor myself. Okay, so here we have our regression syntax so far, and it matches page 100 exactly, except for this last little line, residuals equals outliers, MAHAL. So we need to get rid of the period at the end of this line because that's what shows it that it's done. And we're going to hit enter. And then we're just going to type slash and then all caps residuals there. Let us choose it. Equals outliers. And then in parentheses, MAHAL. Close those parentheses and put a period. And now our syntax matches page 100 exactly. And so what we have to do is click on this number 9, get back up here to the regression one up here. Well, maybe the line won't move. If your red dot is there, you should be good. And then you hit the green button, run selection, and there you go. It just ran the regression exactly for us. And there's a lot of this we're going to ignore because what we're really looking for here is these multivariate outliers. And so where we're going to find that, we're going to hang on to this collinearity diagnostics. We're going to need that later, so skip it for now, but come back to that. We're going to look down here at the outlier statistics. Now this is the Mahalanobis distance that they were talking about on page 99. And as you can see, they describe that case number 117 and 193 are multivariate outliers. And we know this because we're looking at the mean, and I'm sorry, we're not looking at the mean. It describes on page 99 that the chi-square with 5 degrees of freedom equals 20.515. And that's how we know what the distance is going to be. So anything above 20.515 is a multivariate outlier. Now, what they're describing here is this sub-no dependent is a dummy variable, and it's basically just a case label. It's a way to have something that's the dependent that's separate so that you can look at all of the variables together, and that shows multivariate outliers. So it's looking at them together. They're not an outlier all by itself on that specific variable, but combined with other variables, they do become an outlier. And so I don't know if there's a spot that shows us on here that value that they got of 20.515, but for our purposes, we're going to just use their mathematical calculations and believe them. And so we're just following along with what they did here. So you see that 20.649 and 21.837, those are higher than that number of 20.515. They describe that in Appendix C, so it may be something that you can look at later if you're curious. So basically, we want to then understand what is going on with case numbers 117 and 193. And so we're going to find that out next. And so now that we've found them, you would post that syntax, and you would post the charts, the outlier statistic chart. And then if you wanted to go a little further, you would look at section 4.2.1.5, variables causing cases to be outliers. So we're on page 100 now, and we want to try to figure out why these are outliers. On what variables combined do these cases not match? And we want to know that because that really tells us something about our data and generalizability. Don't forget to hit save on your output so that you don't lose anything that you've done. And now what we need to do is compute another dummy variable just to isolate the one case. And so if you look on page 102, it will show you the syntax. And we're going to go to our data set here. We still have these cases eliminated, and that's totally fine. And what we're going to do is click on transform, compute variable, and we're going to put dummy here. We're getting rid of this previous formula we did, and we're just going to put a 0 so that you're going to have a variable where every single one is 0. And then we're going to go ahead and click if down here, and then we're going to put on here if sub-no, let's click that over here. If sub-no equals 137, actually, we might want to wait to do that until after we've run the first one. Let's forget about that for a minute. Sorry to confuse you. We're just going to go ahead and create the dummy variable of 0 for now and click OK. So that just says compute dummy equals 0. So you go back to your data, and here you have a dummy variable, and it's all zeros all the way down. Now what we can do is transform compute variable, and here I think is where we can put, I think maybe we could have done this before. I am sorry to confuse you. As you can see, I'm learning myself. So if the subject number equals 137, I think we need to put this in here. Parentheses, then dummy equals, oops, sorry, hit my numlock there, equals 1. So the subno being 137, that's a little confusing. It's really how they labeled the cases. You can see here in the subno category that they are not matching to what the case number is. And so if you look, the case number we're looking at is 117, and the subno number is going to be 137 for that case. Let's see if this worked, typing this in exactly this way. Nope, the expression is incomplete. So what we need to do then is we need to type the if in here. And if this doesn't work, we can just go back to the syntax editor and do it ourselves that way. Nope, I'm doing something wrong here. So let's go ahead and just go back. We'll close this and we'll go back to our syntax editor. Sometimes my knowledge of SPSS is limited, and so I can see in the syntax what they did, and so I'm just going to go ahead and do that. So what we're going to do is start a new line here and type if, and then in parentheses subno equals 137, dummy equals 1, period. And now we should be able to click on that and run it, right, by clicking that green triangle, and let's see if it did it. Okay, it said execute, and it says what we wanted it to say. So now let's go back to our data, and we're going to look at case number 117. Scroll up till you get to 117. Okay, that did not work. So I honestly forget what I did to compute that, but we can also just go ahead and type it in since we're here. So 1.00, oh, that's interesting. Okay. Run transformations now. I must not have run it correctly. Well, here we go. I'm sorry to take you on a little bunny trail, but let's see what happens. There we go. So we must not have hit OK somewhere along the way, but here we are, and we have successfully done it now. So now what we're going to do is just continue to follow along in the book on page 102. What we want to find out is what variables specifically on that case were significantly different. And so just to do that, we're going to do a regression just for that one case. And so you can follow along with the syntax on the top of page 102. We're going to do that linear regression, and the dependent variable this time is going to be the dummy variable. And we are going to keep all of these independents the same. Our statistics, I think we might want some descriptives as well, because we're just looking specifically let's go ahead and click that. We're wanting the method this time to be stepwise. If you look at the syntax there, you'll see it says method equals stepwise at the bottom. Now, let's just take a look and see if our syntax matches by clicking paste. It'll paste it right into our syntax editor. Go back over there. And here we have the regression, and we're going to compare that with what it says regression on 102. So we added these descriptives, which they did not have. We clicked on that button, so we did not need to do that. We can delete that and delete that. So it goes up to the top. So we have missing listwise, statistics, coefficient, outs. Then we have these other things here which we do not need. That does not match. Oops, keep that S there. And so we have that matching now. Criteria, P in, P out. We have that. No origin, dependent dummy, method stepwise, and all the variables that we need. Now they have employment on here as well, but we've been ignoring that, and just spoiler alert, it's not important. So we're going to go ahead and run that. We'll get to the top here and run this. Oops. Come on. Come on. We'll click. There we go. We'll click run. And now you have the regression, and it's just on the one dummy variable. All the dummies were 0 except for the one case that we want. And so we're looking for that significance there. And you can see that we got this coefficients table that matches exactly the one on page 102. And so we see that for this variable where the one case had a 1, race was significant, attitudes towards medication was significant, and the L time DRS was significant. And so that tells us that on that specific case, case number 117, the combination that led it to be an outlier was race, attitudes towards medication, and the number of times going to the doctor. Now, if we look at that and figure out what does that exactly mean, what were their attitudes and things like that, we can see, where does that show it? Somewhere it did show us, oh, I think we do that a little later. Yeah, we'll find out a little bit later specifically what their status is. So for now, all we need to know is that those variables made a difference. But we're following along the procedure that they did. And so you can see here that we're going to go on to the 193rd case being an outlier. And so that's the next step that we're going to do. And so that's easy enough. Here, let's just hit save on our output. We're going to go back and do what we did a minute ago. But instead of 117 here, that one, we're going to change back to 0. And we're going to go down to the 193rd case over here. And instead of trying to do that through a data transformation, we're just going to take a little shortcut and make it a 1 right there. Okay, now make sure that you did that on the right line. I like to scroll over with my arrow keys to make sure it lines up. I have a 1 in, yep, it's 193, and the sub-no is 262. So that's what we're going to use. And again, we're going to go ahead and do analyze, regression, linear. All of these are the same because our dummy variable now is just going to show us that 262 case. And so we click OK, and down here we see, oh, we forgot to change the syntax. So we have a little extra outputs. Remember, we had gotten rid of the summary and the ANOVA from our syntax editor. This time we did not do that, and so we have a little bit extra. But what it tells us is still the same, and that is, hold on. what we were looking for up here, the coefficients. That's what we needed. So let's look for the coefficients table. Here it is. Here we have the two reasons, the combination of variables that make it a multivariate outlier is race and L time DRS. So the something about the race, we still don't know yet what race it is, but the combination of their race and the number of times going to the doctor in our new variable, that was what it made it an outlier. So now we're looking at page 103, and we are going to just go, and now that we've done both separate regressions, we're going to zip over here back to our data, and we're going to change case 117 back again here. Make sure it's on the right line. Start over at 117. There you go. Highlight it so you can tell. And then we're going to make that a 1. Okay, so now both of our cases that should be 1s on the dummy variable are, sorry there, stop. Okay, so now what we're going to do is follow the list variables syntax, and it's going to give us an output that's just exactly like what it shows us on the bottom of page 103. And so we are going to go to our syntax editor and just type it in because it is easier. So we're going to do list variables. See, it lets us choose, so that's nice. And then we can quickly just copy from right here. These are our variables. Just don't get that period in there. We'll do Control C and a space here, Control V. So there is my variables, and then we're going to do slash on the next line, cases from 117 to 117, period. And then we're going to run that again, list, you know what we can really do easier, copy and paste that whole thing. We're just going to just change the case number. So from 193 to 193. He's going to run these two to show us what those descriptives were. And so then we're going to go enter one more time. Again, we're just copying exactly what's on page 103. Descriptives. There it is. And then these same variables one more time. So we'll just copy and paste that right there, period. That's what tells it you're done. And so we're going to run all of that, but we're going to have to do it in 3 little sections. So we'll go ahead and click run. Here's our descriptives. I think it jumped down because I didn't click on the correct thing. That's okay. We'll need all of it, so it doesn't matter what order it comes in. Go back to our syntax editor. So it just ran this descriptives one because that was the line I was on. So I'm going to go back up here and click into this first one and hit run. There you see it shows us this list that matches exactly the sub-no 137, which we actually did not put that in. And so because we did it in the syntax editor, we don't have that sub-no 137 there. So that's actually an error that we made. And so what you would want to do would possibly be to go in and fix that, because we have we did not put sub-no in our list. So if you want to go back and get that right, you just go back to that syntax editor. See, we started with list variables and then we put in just the other ones, but we need to put equals sub-no, and also down here equals sub-no. Now, when we run that, that should be correct. So let's go ahead and put that again right there. We'll run that one. There we go. Now the subno is listed. So now it exactly matches the page 103. And then we're going to go back over to our syntax editor. And we're going to click down on this next one. And we added the subno in there. So, oops, sorry. This one should be correct. We're going to just click there where it says list variables. And we're going to click run. And that's going to show us this right here that matches page 103. What this tells us, remember the first one, it was race and attitudes towards medication, which is here, this ATT drug, and the number of times that they've been to the doctor. And so we would go back and look at the frequencies, which we got from our descriptives up here. Now, the attitudes towards medication, the minimum is 5, the maximum is 10. In case number 117, which is subno 137, the attitude towards medication was 5, which is the lowest. Now, race here was another one, and that's a 2. That was non-white. So this is a non-white individual who has a very poor view of medications. And also this 1.49 on the new variable, we have to go up here and see the frequencies to see what the mean is. The L time DRS, the minimum would be 0 and the maximum is 1.91 with the mean being 0.74. And so here in this case that we're looking at, it's 1.49, which is pretty high. That's well above the mean. And so the reason this is an outlier is because they have a combination of a poor attitude towards medication and they are non-white, which is a lower portion of our sample, and they go to the doctor a lot. And so we need to think about what that could mean. Let's look at the next outlier and see if there's any similarities, because we know on race and L time DRS, that was also the reason that we had determined that was an outlier. Now here we have again, race is 2, so that's non-white, and an even higher amount of time going to the doctor, almost the highest, 1.91 was the highest. So here what we have is these outliers that tell us that if you are trying to generalize these results, you may have to be careful with women who are non-white, who go to the doctor a lot, and maybe in particular if they have a poor attitude about taking medication. Your results may not be generalizable to that population. And so because those are multivariate outliers, what we're going to do is eliminate those cases as well. And so we've already eliminated the univariate outliers, those scores of 2 on the attitudes towards housework. And now we're also going to eliminate these 2 cases. And so if we were going to do further analysis, we would only have 461 as our n, and so that's what you would have to work with. Okay, so then now we're looking for multicollinearity, and here we actually have already done this. It's just a moment that we're going to go back and look at something. So here we are in our output, which, by the way, let's hit save again. And we'll go up here, way up. Before we did all these things, we had found some collinearity right when we did our outlier statistics. We also calculated right here collinearity diagnostics. This chart is the last one we're going to look at. And I believe that it's described on page 104 in section 4.2.1.6, and it was displayed in table 4.8, which is on page 101. So if you look on page 101, it's a sideways box, it shows you the collinearity diagnostics. And so what we're looking for here is whether or not anything is multicollinear, meaning on all of these dimensions for each of these variables, is there anything that has a combined effect that would create collinearity? And so we do not have any collinearity, and that is, if you look on page 104, it's because the condition index right here, those values have to be less than 30, and they all are. Now we see this one, 28.872, is pretty close to 30, so that might be of concern. But we're also simultaneously looking in each row, other than the constant, to make sure, actually including the constant, I'm sorry, we're making sure that in each row there is not more than one that has a value greater than 0.5 on the variance proportions. And so in this case, you're approaching 30, but there is just the 0.99 here, and there's no other numbers in that row that are 0.5 or higher. So it's acceptable, and there is no multicollinearity. And all these other condition indices are small enough that that's acceptable. And so that's all we needed to look at, and that brings us to the results section. And so if we were going to be doing further analysis, before we got into that, we would want to describe what we did to the data to kind of manipulate it, also to make sure that it was, met the assumptions criteria for normality, both on a univariate and a multivariate level. And so what they have here on pages 104 and 105 is an example of what your results write-up might look like if you're just describing the data screening process. And so you can read that and maybe put some of that in your own words to describe the process that we just went through to get to the places where we got. And remember, ultimately what we did was we eliminated 2 outlier cases, and we then also eliminated 2 other cases that were multivariate outliers. And we also transformed the variable on visits to health professionals using a logarithm in order to increase normality and meet the assumptions of the test. I hope that that was helpful, and that you now have a better idea of how to do data screening and look for normality. So thank you so much.